بسم الله الرحمن الرحيم. السلام عليكم. So we actually will discuss the statistics that we can do on digital images. Okay, what type of statistics we can do on digital images. Actually, here we will give you some of the basic statistics that we can do in different types of images. And we'll see an example of how to make use of this statistics, for example, to improve or to enhance the image that we have. Okay? So, actually, this part, you will not find this part in the book in one fixed place, or one fixed chapter, let's say. So, we'll find that it's scattered here and there in the book. So, here what we're trying to do is just to gather the information in one place and give it to you as one. Let's say one part or one component. So, the topics that we will discuss today, first of all, we'll give you an introduction, what's meant by statistics. Then after that, here we'll introduce the image resolution, which is one important, let's say, factors of the things that we can obtain from the image statistics. Then after that, we'll introduce the image histogram, and we'll see how can we generate and plot this histogram. How can we use this histogram in order to make the enhancement, okay, using something which is called histogram equalization. And at the end here, we introduce some basic concepts of how to analyze the RGB images. Okay? For this slide, the question that we have here, we are saying that what is image statistics? We say that in general, it is anything that you can measure from the image, okay? And any inference, or let's say any deduction that you can get from this image. We say that some signals are more interesting, relevant, important for human vision and cognition. If we apply this on the images that we have, as we have said before, the sensitivity of the human eye is different with respect to the intensity and the color, okay? And we've always said that the human eye is sensitive to what? Is more sensitive to which of these two factors? Intensity. Okay, it's intensity. So actually here we can use some sort of, let's say, statistics in order to put more emphasis on the intensity and make some, for example, discarding or let's say ignoring of some of the color information. Like this, we can make some sort of compression, let's say. Okay? We can use it in order to compress our image. Okay. Another important, let's say, statistics that we have seen before is what is the image resolution. And here by the image resolution, actually I have two types of resolution. Right? Who can give me, and let's say, a hint of these two types of resolution that we have talked about before?
Image resolution and wavelength resolution.
Okay? Actually here we say that image resolution with respect to the size, right? And image resolution with respect to the color. By the size here, I mean the number of pixels that I have in the rows and columns. Okay. Of course, here as the number of pixels increases, that resolution will be better. Sorry, and actually, let's say the quality of the image will be better. But on the other hand, I will need more space to save such type of images. Right. Same thing can be said for the color. Here by the color, the resolution of the color can be calculated or can be represented by the number of bits that I need in order to represent just one pixel. Okay? And we have said that starting from the binary images up to the RGB images. Okay? This can range from 2 bits up to 24 bits in order to represent just one pixel. Of course, here as well, if we put more bits to represent the pixel, this will give me much more resolution. And here, of course, in order to get an information about the resolution of any image, we will use the function which is called what? Size. Okay? So here, in general, if I have an image, even if I don't have, if I don't know what is the type of this image, I will call the size, and I will receive the output that comes from size in 3 variables like this. Okay? Even if this image, for example, is a grayscale image, what will be the value of S here? Will be equal to 1. If it is grayscale. If it is RGB, S here will be equal to 3. Right? Of course, here R and C, these are the number of rows, and C is the number of columns. Okay, this is evident. Okay. Now let's look at the histogram. What do I mean by histogram?
Statistics.
Yes, it's one form of statistics, but how can I apply it on an image? Okay, if I have, for example, a histogram like this one, okay, there I have horizontal axis and vertical axis, and the result of the histogram I have things like this. In this case, what does the horizontal axis represent and what does the vertical axis represent? Provided that I have here, let's say, an image that has a number of rows R, a number of columns C. Yes?
The horizontal line is the colors.
Yes?
And the vertical line is how many pixels that have this color.
Exactly. So here actually, if we apply it on a grayscale image, for example, okay, so we'll find that the horizontal line here, it represents the different intensity levels that we have. Starting from, let's say, 0 up to the maximum value here, it will be, for example, 255. And the vertical axis here, it will give me how many pixels are having each one of these levels. Okay? So I have, for example, this is level 1, 2, 3, 4, and so on. So this is the number of pixels having this level. Okay? So here we say that intensity transformation functions based on information extracted from image intensity play a basic role in image processing. As you will see later, I can make use of this information in order to enhance the quality of my image, okay? In order to increase the contrast in this image, okay? Making a bigger difference between the brighter pixels from the darker ones. Okay? So here we can use it for enhancement. Also, we can use it for compression. Also, we can use it for segmentation and description. Here for the compression, as we have said before, we can say that if I find, for example, that most of my pixels actually is about a certain number of, let's say, intensities, in this case, I can reduce the number of levels that can be represented per bit to this specific number of levels. Okay? So like this, I can compress the image by reducing the number of bits per pixel. This is one thing. This is for the compression. For the segmentation, here, for example, if I have, yes, we'll look at the segmentation later. But the segmentation here, the basic concept of it, is that if I have an image like this one, and I have two objects, okay? In this case, I want to recognize where can I find each one of these objects in my image. In other words, what is the location of these objects in my image? Okay? This as well can be defined or can be obtained by making some sort of analysis to the histogram that we have. Okay? Just for example, here I have this one, it has a certain, let's say, range of values. Let's say, it is between 100 and 200. And this one, for example, it has a certain range of values, between 20 and 70. Okay? So like this, for example, I can put, after doing my histogram, I can obtain this information. So here between 20 and 70, I have here, let's say, a certain large number of pixels. Then after that, here I have a certain region in which I have the number of pixels is low. Then after that, the number of pixels will increase again, starting from 100 to 200. So like this, if I put a threshold here, I can distinguish between which pixel belongs to which object. You understand the idea? So this is what's meant by segmentation. So here we say that the focus of this section is on obtaining, plotting, and using histograms for image enhancement. In this case, actually, we will talk about the image enhancement, okay? And later we'll see how can we use the statistics to make the segmentation. Any questions? Okay. So now let's see the first topic here that is related to the histogram. How can we generate this histogram? Of course, we have in MATLAB, we have functions that can generate the histogram automatically and all of these things, but we need to understand how it is generated in the first place. So here we say that the histogram of a digital image with N total possible intensity levels in the range from 0 to G is defined as the discrete function h of rk is equal to nk. Here RK, actually this is the K intensity level. This case is the intensity level. So here RK actually can have the value. If we are talking about grayscale, for example, it can have either the value of 0, 1, 2, 3, up to 255. So here when I say, for example, h of 0 is equal to a certain number, this means that this is the number of pixels that are having the level 0. Okay? So nk here, it means the number of pixels that are having the intensity level rk. Okay? And of course here rk is in this interval from 0 up to g. Okay? And nk is the number of pixels in the image whose intensity level is rk. So, if we look at the definition from the beginning here, we'll find that I have another parameter which is called what? L. L here is the total number of possible levels that we have. Who can give me what is the relationship between, if I'm talking about the grayscale level, what is the relationship between L and G? It's very simple. L is the total number of levels that I have. Okay? While 0 to G, these are the value of the levels. Okay? So if I say that I have a grayscale image, what will be the range of the values for each pixel? It will be from 0 up to 255. Okay? L, it means how many levels, how many total levels I have in this range. So here in this case, I will have 256. So here we can say that L is equal to G plus 1, or G is equal to L minus 1. Right? Very simple. Here we say that the value of G is 255 for images of class unsigned integer 8, and it is equal to 65,535 for images of class unsigned integer 16. Actually, unsigned integer 16 is not widely used. We, most of the time, are using the unsigned integer 8. Okay? But for double, as we have seen before, the maximum value of G is what? Is 1.0. We know this. Here also we say that keep in mind that in MATLAB, it cannot be here the indices, here the index of the elements. The first element, what is the index of the first element, and the second, and so on. So actually here it starts from 1 instead of 0. Okay? So here when we talk about, let's say, R1, where 1 here corresponds to the K, which is the index, this will represent intensity 0. Okay? So here we say that R1 corresponds to the intensity level 0, R2 corresponds to intensity level 1, and so on. Okay? So this is something that we should take care of. Yes?
I couldn't get it. R1 is the index of the text.
R1? Yes, R1 here. Actually, this is the intensity level value.
Yeah, so
what is the first intensity level value that we have? It is 0. Okay? 1 here, this is the index that is used by MATLAB to represent the first value of intensity levels. Okay? So if I want to put this intensity levels, let's say, in a vector in MATLAB, it will be something like this. 0, 1, 2, 3, 4, up to 255. Right? If I want to access this first element, its index will be equal to how much in MATLAB is 1. The next one here, it will be equal to 2. And so on, up to what? 256. Okay? Right? Simply, and it's just something that is MATLAB related. It is not related to the image processing in general, but this is something that is related to implementation in MATLAB. Also here, how to plot a histogram. Here in the MATLAB, we have a function that exists in the digital image processing toolbox, which is called imhist, which is the image histogram. So first of all, I need to read the image. Then after that, I will just call this function. Okay? If I don't want to plot it and I want just to store it in a matrix or something, I will make it something like this. H is equal to im histogram of x. Okay? So, let's see a quick example here. If we take this example, okay, Control C. Control V. Here the image is called tire.tif. And here, if I want to plot the histogram directly, I will just call IMHist with the matrix that contains this information. So actually here I will have a histogram like this one. So if you look here at this histogram, you'll find that the levels, they are from 0 up to 256. Okay, it is above 250 with the little bit which corresponds to 156. Here, according to the size of this image, what can I deduce from as an information about the type of the image? It's grayscale. Okay, most probably it's grayscale. And here, as you can see, according to this histogram, we'll find that the majority of the pixels are bright or dark here. They are dark, okay, because actually here I will have high peaks at the low region of intensity. Okay? To have an idea about this picture, here is the picture or the image that we are talking about. I am sure of X. This is this one, okay? It's an image of a tire. As you can see here, the majority of the pixels here are having dark values. Right. If, for example, I want to store the information that I got from this histogram, I will make the same thing. I will call the same function, but I will put h equals, or a certain variable equal the returning value of this function. So here, as you can see, I have h. It has what's the dimension of h that is generated here?
1 column.
Yes, it's 1 column and 256 rows, so it's in the form of a vector. Okay, where the first element here that has index 1 represents the number of pixels that are having intensity 0. Okay? So here it will be something like this. The first element here in this vector, it represents what? It represents the number of pixels, okay, that are having intensity level of 0. The first intensity level. Okay? If I will go to the second element, it will give me the number of pixels that are having the intensity level 1, and so on. And here the last element here in this vector, which is element 256, it will give me the number of pixels that are having the intensity level of 255. Exactly. Clear? So here we can say something like this, h, if I want to see the first element. Can I do something like this? H of 0? No. Actually here I should start with index 1. 477 that I have here, sorry. This is what? Number of pixels having the intensity 0. Sorry, intensity 0, yes, sure. Right. If I say, let's say, I want to go to end. Okay? H of end here, it represents what? Let me make sure here. Here we have 256. Yes, and here this is the index of the last element. So here, the 301, this is the number of pixels that are having the pixels that are equal to 255, that are having the level of 255. Okay? Right. So this is one thing that we know. So now we have seen how can we generate and plot the histogram. Okay. Here it's saying that we often use normalized histogram, which is obtained by dividing all of the elements of the histogram values that we have by the total number of pixels that we have in this image. Okay? I have a question before talking about this normalized histogram. If I have an image, grayscale image, let's say, it has this size of R rows and C columns, okay? And I found that my histogram, I can have a shape like this one, say, okay? This is 0, 1, 2, 155, okay? So this is the histogram of the image. Okay? Right. If I will add up all of these values together, what should be the value of the total number? It's total number of pixels, which in this case will be equal to R multiplied by C. Okay? Right. Here, when he talks about the normalized histogram, he has said that I will divide all of these values by the total number of pixels that I have in the image. Okay? For example, here, what will happen, instead of having, let's say, intensity 1 here, I have the value of 100. For the normalized value will be equal to 100 divided by R multiplied by C. And I will apply it for all of the different intensity levels that I have. Now, if I sum up all of these values together after being normalized, what will be the total here? 1. Exactly. It will be equal to 1. Right? It will be equal to 1. So here we say that, which is obtained by dividing all of the values of the total number of pixels. So here, that's why here, when he talks about the normalized histogram values, he's using the letter P, where P here corresponds to the probability. Okay? So here when I say that the probability of having a certain level RK, it is equal to the histogram value of the RK, which is the number of pixels that I have in this value RK, divided by the total number of pixels. Okay? Right? Where K here, of course, correspond to the different levels that we have. Okay? So here we say that P of RK is an estimate of the probability of occurrence of this intensity level. Okay? You can look at it as something like this. And this kind of calculation, actually, it will result in a value, or let's say in a physical quantity that's called probability density function. Probability density function. I think you have heard about the probability density function before. Right? So here, for each one of these images, I can create, let's say, its probability density function. What do I mean by probability density function of an image? Is the probability that a certain pixel can have a certain intensity level. How can I get it? I can get it from the normalized histogram. Clear? The idea is very simple, as you can see. Fine. Now here the plotting of the histogram, it can be, in most of the cases you are plotting it using bars, right? Some cases you can use, for example, other thing, which is something which is called what? A stem. A stem, this means it is a vertical line as well. Okay, but at the top I will have a circle, as you will see. Or I can plot it in the form of a line, and in this case I can connect, let's say, the top values together. So in this case I will have a curve. Okay? So here, in order to represent it using bars, I can either use the IM_hist function directly, or taking the values that I have obtained from the histogram and apply the function bar. And here for this bar, it will need 3 arguments, as you can see. Here I have horizontal, V, and width. Where V here, actually, this is the row vector containing the points to be plotted, which is the result of the histogram that we have. Okay? Horizontal, this is a vector of the same dimension as V, and contains increments of the horizontal scale. Well, here, actually, it corresponds to the different intensity values. For example, 0, 1, 2, 3, up to 255. And width here is a number between 0 and 1. When width is 1, the bars touch. Actually, here we'll see how this width can vary the shape of the figure that we have. So, this is one thing. So actually, it will be something like this if we apply it on another image that is called cameraman.tif. This as well as another famous image. And I get the histogram, okay, which is the vector that corresponds to the number of pixels that are having different values of intensities. Okay, I will create a vector having the steps of 10. And here I have horizontal. It will also have a vector starting from 1 up to 256 with steps of 10. And I will plot the resulting expression that I have here. So as you can see here, from 0 to 256, instead of having the number of pixels that are having single, let's say, levels, Actually, here I will have the number of pixels that are having the levels from 0 up to 9, let's say. Okay? And here I have the number of pixels that are having the levels from 10 up to 19, and so on. Okay? So it's up to me to specify what will be the width of the bar. Okay? Then after that, here, what we have actually after that is the axis. Here we can control what will be the range of the axis, from 0 to 255. This is for the horizontal axis, and from 0 to 1400 for the vertical axis. And here, these are the ticks that will appear here. Actually, it doesn't appear clearly here. Because here I need to put some sort of ticks between these values. Okay? And here I can specify what will be the range of the tick, the distance between one tick and the next one. So here actually it will be in the form, here it is 50, but here it is what? It is 100. Then after that, here I can give the label, X label, Y label, and a general title for the plot that I have. Okay? So all of these functions, these are related to the plot itself. They are not related to the histogram. They are related to how can we plot and enhance the plot and put more information on it. Okay? So here is how can we do it using the bar. Now here, this is another thing here. Instead of using the bar here, we're using what? Stem, as you have said before. It is similar to this one, but instead of having the bar that has a certain width, actually here I can have something like this. These are the corresponding values, and at the top here I will have just a circle to denote that this is the top point. Okay. Also, we can use the normal plot that we have seen before. In this case, the tops will be connected together, so we will have a histogram in this way. Okay? So these are different ways of displaying the same histogram, either using the bar plot or stem. Do you have any question here? Now let's look at the histogram equalization and how can we use this equalization in order to enhance the image that we have. So here we said that the histogram equalization is a method in image processing of contrast adjustment using the image's histogram. What do I mean by this? What do I mean by histogram? Let's say adjustment of contrast of a certain image. Let's compare between these two histograms, the one on the left and the one on the right. What can you deduce from these two histograms? Here actually in the first histogram, we'll find that the pixels that are having the lowest possible value that exist here in this image, and the values, the maximum values that exist in the same image, the difference between them is somehow small. So this means that I don't have enough contrast between the different pixels. Okay? More or less, I will feel that most of the pixels are having almost the same intensity. Okay? Right? While here, if I take this same image and I try to stretch the values that the pixels can have among all of the possible levels that it can have, in this case, I will enhance the contrast. So the range between the pixel that has the maximum value and the pixel that has the minimum value here has increased. So like this, the difference between the pixels actually has increased as well. This means that the contrast between the pixels has increased. This may improve the image. This may improve the image quality. You understand the idea? So here actually, instead of having this narrow range of values for the pixels, I have stretched their values among all of the levels that the pixel can have. Instead, for example, of being confined between 100 and 200, here it will be between 0 up to 255. Okay? So like this, the contrast will be... Yes?
For example, in the first graph, does that mean that there is pixels that have extremely low intensity?
Yes. Here, for example, if I make the histogram for this image, I will find that, say, after the level of, let's say, 150, I don't have any pixels that are having values greater than 150. Okay? So if I put something like this, it's 150, and this is 50. So this means that all of the values from 150 up to 255, I don't have any pixels that can have these values. Okay? The same thing can be said here. I don't have any pixels that are having values between 0 up to 50.
So the next graph, this.
The next graph, what I want to do is that I want to stretch the values that these pixels can have among all of the ranges that I have here. So this means that I want to move this pixel here
To have lower intensity.
to have lower intensity,
Yeah.
and this pixels actually will be moved here to have higher intensity, but this is to be done in a linear way.
Okay.
So I will stretch the range. Instead of having a narrow range, it will have a broader range or a wider range in order to cover the different intensities. Yes?
So, but at the beginning you said that we should focus on the intensity and then ignore the.
Exactly. Here we are just talking about intensity.
But here the intensity is lower.
The
intensity is lower than before.
Yes, the intensity is lower for some pixels, okay? The pixels that are having the least intensity, I will decrease them more and more. And the pixels that are having higher intensity, I will increase their intensity more and more. So like this, the contrast will increase. By contrast here, I mean the difference between the intensity of two pixels. Okay? So here instead, for example, of having a delta difference, here I will have 2 or 3 delta. Okay? So like this, the contrast will increase. This means that the details inside this image will appear in a clearer way. Understand the idea? Maybe if we see an example here, I think we have in the next slide. Let's apply it here. Oops. Okay, so here. So let's see. Okay, he is suffering from this one, no problem. You will correct the single quotes. So now we have an image that's called pout.tiff. Okay, now we have read this pout.tiff. First of all, here, as you can see, what is the type of this image?
Gray.
Seems that it's a grayscale, right? Has this information type. Now let's look at, here. We have a function that is called histogram equalization. Okay? So it will not just compute the histogram, but as well it will make normalization for this histogram and it will make some sort of equalization for it. Okay? So it will stretch the histogram. It will see what is the minimum value, what is the maximum value, and it will stretch it among all of the range. So here we have this. So I will give it the image F, and it will result in image G. Okay? So we'll see. Okay. Ya Allah, show this nice little girl. We have here, this is the original image, okay? And this is the image after equalizing its histogram. So as you can see here, we have made some sort of enhancement, okay? The contrast here has increased, right? But here, if you look at this image, you will find that the value between the maximum pixel and the minimum pixel is narrow if we compare it with this one. How can I prove this? Just draw the histogram for each one of these two images, okay? So here we'll have, in this part, Control C. So this is the histogram of the new image, and this is the histogram of the original image. As you can see, this is the histogram of the original image. Now it has been stretched among all of the range. So like this, we have increased the contrast of the image. Yes. Clear?
Yes.
Any questions here? You understand the concept here? It's so simple. Just we are trying to make use of the full range of the possible values. Yes? Exactly. في pixels الإضاءة بتاعتها زادت. We have some of the pixels that has became brighter and other pixels that has become darker. So in general, if we look at the whole pixels together, we will feel that it has been, we say that it becomes more clear. Okay? I can make a comparison easily between the different levels of the pixels. Okay, so I can see more details.
But the actual number of shades or the shade levels didn't increase, right?
Yes, it didn't increase. But here actually he's using a very small number of these levels. And in this image actually I'm using all of the levels that I have. Okay? So here what the levels that are used here, okay, I will try to stretch it in this new image. Okay? So if we take let's say 2 pixels here, let's at the nose here, we'll find that here it will be brighter than in the original image. Okay? Also if we take another pixel, let's say this black pixel, here it is brighter than in the new image. So the dark pixels will become darker and the bright pixels will become brighter. So like this, the contrast will increase. Okay? So here we have, as you have seen, the histogram equalization. We have done it with just one code to the hist equal. It's called HISTEQ function. Okay. In this slide, he's giving us an information. How can we make this histogram equalization? How can we produce? Here we know the probability density function, right? Now here we'll produce another thing which is called cumulative distribution function. Okay. You have seen this before in the probability and statistics? Okay? Cumulative distribution function. We will see what is the meaning of this one. But here these are the steps. So given a grayscale image, get its histogram. Get the normal histogram that we have. Then from this histogram, get the PDF. How can I get the PDF from the histogram? Just normalize it. Divided by the number of pixels. Okay? Then from this PDF, we will get the cumulative distribution function. The operation is very simple. If, for example, at a certain level, I want to get the cumulative distribution function, what will happen is that I will add all of the probability density functions of all of the values of Rk that are less than or equal to Rk. Okay? So here, for example, if I want to get the cumulative, we'll call it something like this, T of level 3. Okay? This actually, if we look at this expression, it is the summation of P of 3 plus P of 2 plus P of 1 plus P of 0. Okay? So it is the summation of all of the probabilities of the different intensities, starting from this intensity down to intensity 0. Okay? So here I can see that this function actually it is an increasing function. Okay? Or to be more accurate, it is a non-decreasing function. Okay? As we'll see later. So when we say that for K here corresponds to the indices, or let's say the index of the level in MATLAB, which starts from 1 up to n. So it will be from 1 up to 256. Where Sk here is the intensity value of the output image corresponding to the value Rk. We'll see here how this is considered. Actually, first of all, for this original image, I will get its histogram. I will get its probability density function by normalizing the histogram. Okay? Then after that, for this probability density function, I will compute its cumulative distribution function. Okay? It will be something like this. As you can see from here, the levels that are having low intensity, its probability is equal to 0, because actually I don't have pixels that are having these levels. So if I will accumulate them, it will be equal to 0. Starting from this pixel, I will have non-zero values, and it will increase. Okay? Up to the maximum intensity that the original image have, I will find that here the cumulative distribution function will reach the saturation value, which is 1. And it will continue until the end. How can I make use of this information to generate this bottom image from the upper one? I will make a very simple mapping. Okay? Assuming that these are the levels, intensity levels. In this case, I will consider that the intensity level has the double value. Okay, so the intensity level, it will range from 0 up to 1. Okay? And here as well, for the cumulative distribution function in the vertical axis, I have the levels from 0 up to 1. Okay? Right? Right. Then after that, how can I generate this image from that one using this information? Who can tell me? I will just show you the previous slide, just to give you a hint here. If you look at this point, compute the cumulative distribution function, okay? For each level Rk, I will compute Sk, right? And here we say that for k is equal to 1 up to L, okay, which are the indices of the different level values, where Sk is the intensity value in the output image corresponding to the value Rk. So this means that for each level Rk, it will be substituted by the value of Sk. What's the meaning of this? It is saying that I will compute the cumulative distribution function, right? Okay? And the value of S of k, which is the intensity from 0 to 1, okay? It will be representing the intensity value corresponding to the value Rk in the original image. Okay? Will be corresponding to the value of the original image. So here, what will happen is the following. This is what we can say, these are the different levels that we have. And this is the cumulative distribution function that has been generated. Right? Okay? Fine. Here, how can we convert from this image, the original image, to the new one, based on the information that we have just seen before? There's more or less some sort of mapping, okay? These are the ranges, okay? These are the possible ranges that we have in the original image. It will be expanded over all of the range from 0 up to 1. It will be expanded over the whole range from 0 up to 1. So how can we do this? I just want to give you a couple of minutes just to think about it. Then after that, we'll go through this code to explain it step by step. Okay, any ideas? Okay, let's look at this code here. Maybe things will be clear. First of all, before proceeding, do you have any ideas how to enhance the contrast of the image using the CDF?
When we code by the first pixel, we take the first CDF value.
Yes.
Then the second pixel, we take the second one.
Yes.
So on.
Yes. Here you see the following, which is that here I am assuming that the original image is F, right? That has these narrow ranges of values. Let's assume that the range of values for the F here, according to the histogram, assume, okay? It ranges from 100, let's say, مثلا, to 150, let's say. Okay? So accordingly, if I look at its corresponding CDF, I will find that the value that corresponds to 100, the value that corresponds to 150, I will find that its corresponding CDF will be something like this. Right? Okay? Fine. Here, according to this loop, first of all, assume that I want to read the value of the pixel in row I and in column J. It will give me n. Of course, here, n, for example, if it has a certain value, it should have a value within this range. Mainly, it will be within this range. So if I have my value n is equal to 100, okay, I will take this 100, okay, and I will apply it here. And according to this CDF, I will go to the value of 100 and get its corresponding CDF. What is the corresponding CDF for 100? It is 0. Okay? If I have another value, let's say مثلا that I have found that the value of the pixel here is 150. Okay? So I will go here to the CTF and see what is the corresponding value of the CTF value for 150. So I will go here. I will find that 150 here corresponds to what? To 1.0, or let's say 255. Okay? So like this pixel of this value have been mapped to the smallest value in the range, and this pixel with the maximum value has been mapped to the maximum value of the range. Here I am expecting if I find any value here in between, it will be somewhere here, within this range. So like this I have expanded the range of the pixels that I have. So here the idea is that the steps are straightforward. Compute the histogram of the image, normalize the histogram to get the PDF, the probability density function. Then from this PDF we will apply this function. This will compute the CDF, which is the cumulative distribution function. It will give me the CDFs here. The CDFs, of course, it will range from 0, as we have seen here, to 1. Clear? Okay? Fine. Once I have this, I will pass over all of the pixels in the original image one by one. Get its corresponding level. Okay? And I will get this level and I will use it as an index for the CDF. So for the pixel that has the value, the minimum value 100 here, if I will get its CDF, it should give me 0. And the pixel that has the maximum value here, if I get its CDF, it will give me 1, which corresponds to the maximum intensity. Anything in between will give me an intensity in between. So like this, I have expanded the range that I have, original range of the image, to the full range that I can have in any image that starts from 0 up to 1. You understand that bit? So that's why here we'll find that the contrast of the image has been improved. Okay? Been considerably improved. Is it clear? Fine. I have another, just, yes, sorry.
So the picture, this one, which you show us, the result is after applying the CDF.
Yes, exactly. Okay? So this is the original image and this is the image after enhancement. Clear? Fine. Also, there is a very useful function that we'll see if we want to make an analysis of the image colors. We have a function that's called IMPixel. IMPixel, it will allow me, for example, if I have in front of me a window in which I have an image that is already displayed, if I can select a pixel by the mouse, okay, and I click on it, it will give me an information about its color. Okay? So like this can allow me, for example, to create my own color map. If I have an image and I want to create my color map manually, I will click over the different pixels that I have that are having different colors, and I will see what will be the different components of these colors. Let's consider it. Here we will create a simple, we'll create a simple image just to illustrate the idea. RGB image analysis. Okay, so here we have an image like this one. First of all, I am assuming that I will create the image myself, right, in order to have simple colors in it. So here we will create a matrix of 256 by 256 by 3. So this is the color RGB, right? And the type of the matrix here is unsigned integer A. So this is one way of creating a matrix that contains zeros. Okay, I can provide it with this 4 arguments. And then after that, I will divide this image into 3 regions, as you will see here. Actually, it will be 4 regions. I will assume that the red will be equal to 255 in the first 128 rows, and the green will be equal to 255 in the rows starting from 65 to 192. And the blue will be equal to 155 in the rows 128 to 256. Actually, it will be something like this in the form of bands, okay? But they are overlapping. So some pixels will have just red component, other pixels will have red and green, other pixels will have green and blue, and other pixels will have just blue. Okay? So the resulting image will be something like this. I expect to have 4 regions like this. Okay? Red, this is pure red. Here I have a combination of red and green. Here I have a combination of green and blue. And here I have just blue. Okay? The function that I can use in order to select some of the pixels and get their corresponding colors is called IMPixel. And this IMPixel, I will pass to it the matrix that contains the image, and the resulting, let's say, selection, it will be stored in map. It works the same way like G-input, but the output is different. It will give me the color components instead of their positions. Okay? So I will select the pixels by just clicking on the different colored regions, and at the end I will press enter. So let's assume that I will call it something like this. Once I call this function, you will find that the image will come on at the top again. So here I will make something like this. Just a moment. Here we have it. Control C, Control V. This is not the correct function. It should be map equals RGB. Control C, Control V. Okay, so here we have it. Okay, and when I come over this, as you can see here, I have the crosshair. So for example, I will select this one, and the blue one, and the cyan one, and this one. Okay? Now I have finished with my selections. I will press enter. So in this case, I have the map of the colors. The first element that I have selected is RGB components. Okay? So this was a pure red. This is red with green. This is green with blue, and this is the blue. Okay, and we can do it, of course, in any type of image. For example, if I want to get the color, exact color of a certain pixel on the screen, just call the IMPixel with the matrix that contains this image, and go with your cursor of the mouse, click on it, then press enter. You will have the information that you have, that you need. Okay, so here, as you can see here, the map, it has created 4, which corresponds to the different 4 positions that I have clicked on. For each one of them, actually, I have the 3 components for red, green, and blue. Okay? So like this, for example, if I give you a problem telling you if I have a color image and I want you to create its corresponding color map, I want to convert it into an index color image. It will be simple, especially if I have, the colors are well defined, like in this one. So what I need in this case, first of all, to call this IMPixel function, get the information of the different colors that I have, put them in a matrix like this one, know the index of each entry in this matrix, and for each color, I will put its corresponding index. For example, instead of putting, let's say, for the yellow, 155, 155, 0, if I have this is my map, I will put the index of this entry, which will be 2. Okay, and for the red, I will put 1, and for the blue, I will put 4, and so on.
So we will do like for loop and step inside the for loop.
Exactly. So it will be in the form of the for loop. Before doing this for loop, first of all, I need to create my map. Okay. Then after that, I will go through this for loop, pixel by pixel, compare it with the entry of this table, and wherever I find the corresponding color, I will replace this entry by the index of the color in the map. Okay? Clear? Fine. So we'll stop here. And inshallah, next time I will show you how can you capture videos using your laptop. Okay? I will show you how can you capture videos using your laptop together with the new topic that you will study today. Okay?